week 10's screencast on integration application. And to this will be tutorial 1 on how we use integration to solve questions on cost concept, revenue, and consumption functions. In the cost concept, we'll be looking at how to derive the total cost from your marginal cost. In the revenue also, we'll look at how to derive the total revenue from the average revenue and even the demand function. And then the consumption functions, we shall see how to determine the consumption functions from marginal propensity to consume. Now let's look at example 1. It says that a certain factory, the marginal cost is given as 3 into bracket Q minus 4 squared rands per unit when the level of production is Q units. And by how much will the total manufacturing cost increase if the level of production is raised from 6 units to 10 units? So here we're looking at the total cost, how to determine that from the marginal cost. And if you remember from the lectures, to determine the total cost from the marginal cost, we integrate the marginal cost. This is your total marginal cost with your CDQ. So to be able to find the total cost there, we integrate that. And it will be a definite integral because we are given the values of Q from 6 to 10. So it is definite integral of 6 to 10 of that. Now to integrate this function, it's like we have to apply your integration by substitution. It's easier by just adding 1 to that, makes it 3, divide by that. That gives you Q minus 4 to the power of 3. Now, in the one in the bracket should be differentiated and then you solve for the Q. If you do that, it should give you 1 if you differentiate that. So obviously, it's not going to affect the function, which means that the function 3 means Q minus 4 to the power of 3. If you differentiate this, this is what you're going to have. So it's still fine. And then what do you do next? You substitute for 10 in your Q and your 6 in your Q. You substitute these values and subtract them, the smaller one from the larger one. Now remember that this is definite integral, so we need to have a value. But if you're going to look at it, this is your total cost function. The total cost function is Q minus 4 to the power of 3. And then the value of total cost from 6 units to 10 units is 280 Rand. Now let's look at example 2. In example 2, we are told that suppose that T years from now, one investment will be generating a profit of that, P prime 1 of T, 50 plus T squared, 100 Rands per year, while the second investment will generate a profit at the rate of that, P prime 2 T, 200 plus 5T, 100 Rands per year. Now we're told to find how many years that the rate of profitability of the second investment exceed that of the first. We are looking at difference in profit between two investments. This is what we know as the excess profit. And so to find the time that we take this investment to the profit of this investment to outgrow the profit of the first investment, we equate the two values for P of T. So that is what we are doing here. And then you solve for T. If you do that there and solve for T, equating to 0, you have that. If you collect all the terms to the left hand side of the equation. And then what you do here, you factorize. In factorizing that, the factors of 150, that when you multiply it will give you 150 and when you add it will give you 5, the factors are minus 15 and plus 10. You could as well use your formula method of minus b plus minus square root of b squared minus 4ac over 2a to solve that if you cannot factorize. And then from there, if you solve for t, t gives us 15 or minus 10. Or we'll rather take 15 because it's feasible to have positive years and not negative ones. So 15, it will take 15 years for the second investment to outweigh the first investment in terms of profitability. That's how to find the excess profit time factor. Now the second one says, if you go back to the question there, it talks about computing the net excess profit for the time period. So here we're looking at the net excess profit. It means the total profit that will have been made between the two investments, having known the years it will take for it to outweigh the other. So let's look at amount of profit made. So what do we do here? In this case, when we're looking at net excess, we integrate the difference between the two. Okay? Right, so you can take this as a function because that's the difference between the two investments, And that is what we're trying to do here. If we subtract that, it's going to have that. And then what do? You integrate them one after the other. If you integrate 150, it gives you 150t. If you integrate that, t to the power of 1 becomes 1 plus 1 gives you 2. And you divide that by 2, it gives you 5 over 2 t squared. You integrate that, add 1 plus that gives us t cubed, divide by 3. And then since the period is from 15 to 0, so this should be 15 to 0, or 0 to 15. That means that is our time period. How do we know that? Because the time is given there from where we solved in the first example. And so what do we do now? At this point, we just substitute 15 there for the values of t, you get your answer. You substitute 0 for the values of t, you get your answer. You subtract the two answers, that is what you will have. That is on how to calculate the net excess profit. Now let's look at the revenue function. In this case, we'll be given the marginal revenue, which is our DRDQ, and we'll be told to find the total revenue or the demand function. Now, in deriving the demand function from a total revenue function is for us to divide the total revenue by Q. So the first thing is determine the total revenue from your marginal revenue, and then you divide that function by Q, and you can determine your demand function. Let's look at an example. The marginal revenue is given as 200 over Q plus 2 squared. It means we need to integrate that to get our total revenue. And don't forget, I said you divide by Q to get your demand function. So let's first of all integrate that. To integrate that, I can decide to bring this up. It becomes a negative. I'm still going to be using my substitution method. And so I have that. I bring the 200 out of the integral sign. I will integrate that. Add 1 to that, it gives you minus 1. Divide by minus 1, it gives you that. And then don't forget also that since you be differentiating that in the brackets gives you 1, so it does not change the equation, but still becomes your integral of that. And so don't forget that we are told that this is our total revenue function, but because we are determining the demand function, we divide all by Q. I divide all of this equation by Q. If I rewrite this equation, it becomes like that. And so if I divide by Q, dividing by Q means reciprocal of Q. So if I divide by Q, it becomes 1 over Q when I times it, and that will give me that. So that's my demand function from that marginal revenue.